So that creates tensions, and that's what I want to talk about, because I think it's important that we are, as a society, able to have an informed debate about how much privacy is enough but not too much, how much security is enough but not too much. In the physical world, we've got all kinds of protections. This is evidence that we care about our privacy. We've got doors, we've got obscured glass, we've got locks, we wear clothes. And technology continues to erode the privacy that exists in the real world, in the three spatial dimensions. Security cameras, automatic number plate recognition take away anonymity. Long lenses, paparazzi, take away distance and the privacy that used to create. And body scanners are increasingly being used to see through clothes, for example. This process isn't going to slow down, and the new quantum technologies are actually being able to do gravitational sensing, and that's advancing at a remarkable rate, and you can't shield gravity. So some of the new quantum technologies are able already to see through walls, and there are technologies also for seeing around corners now using scattered light from lasers.
We appear to take it as a rule, or as a law of nature, that each species is adapted to the climate of its own home. For example, species from the Arctic, or a temperate region, could not survive in a tropical climate, nor could a tropical species last long if it found itself at the South Pole. But it is true to say that there's too much emphasis placed on the degree of adaptation of species to the climates where they live. We assume that this adaptation, if all species are descended from a single form, must have taken place over millions of years, yet a large number of plants and animals brought from different countries remain perfectly healthy in their new home. Also, there are several examples of animal species that have extended their range, within historical times, from warmer to cooler latitudes and the other way around. Rats and mice provide good examples. They have been transported by man to many parts of the world and now have a far wider range than any other rodent, and can be found living in the cold climate of Faroe Islands to the north, to the tropical zones, to the Falkland Islands in the south. It is possible to see adaptation to any climate as a quality that is part of an inborn flexibility of the physical and mental constitution of most animals. Therefore, the ability to survive in most different climates by both man and his domestic animals, and the fact that elephants once existed in an ice age while living species live in tropical areas, should not be seen as deviations from the rule, but as examples of this flexibility being brought into action under particular circumstances.
And these photoreceptors in your eye are an extraordinary piece of engineering. Do you know how sensitive a photoreceptor can be? What's the absolutely minimum possible detectable unit of light. 1 photon. Turns out your photoreceptors can, under appropriate circumstances, detect a single photon. Not in the bright light, but in dark adapted conditions, you actually have 1 photon sensitivity. Very impressive. Under appropriate conditions, mind you. Sound receptors. You've got sound receptors in your ear, and they're beautiful. We're not going to talk about them at any length, but there's little flappy, these little spiky things going along in your ear, and they can translate vibrational energy coming from your ear, hitting your eardrum, being translated into a vibration in the fluid in your ear, into a physical motion of these little receptors there, into an electrical motion, into an electrical signal that goes into your ear. So all that's pretty impressive stuff. We're not going to talk about the details of it, but I invite some of you who want to learn more about this, particularly MIT students, I think, find receptors to be really quite remarkable kinds of devices.
In 1943, what became known as the Green Revolution began when Mexico, unable to feed its growing population, shouted for help. Within a few years, the Ford and Rockefeller Foundations founded the International Rice Research Institute in Asia, and by 1962, a new strain of rice called IR-8 was feeding people all over the world. IR-8 was the first really big modified crop to make a real impact on world hunger. In 1962, the technology did not yet exist to directly manipulate the genes of plants, and so IR-8 was created by carefully crossing existing varieties, selecting the best from each generation, further modifying them, and finally finding the best. Here is the power of modified crops. IR-8, with no fertilizer, straight out of the box, produced 5 times the yield of traditional rice varieties. In optimal conditions with nitrogen, it produced 10 times the yield of traditional varieties. By 1980, IR-36 resisted pests and grew fast enough to allow 2 crops a year instead of just 1, doubling the yield. And by 1990, using more advanced genetic manipulation techniques, IR-72 was outperforming even IR-36.
The brain is basically built from the bottom up. First, the brain builds basic circuits that are responsible for basic skills, and then more complex circuits are built on top of those basic circuits as we develop more complex skills. Biologically, the brain is prepared to be shaped by experience. It's expecting the experiences that a young child has to literally influence the formation of its circuitry. It's built into our biology. The interaction between genetics and experience that shapes brain architecture is embedded in the reciprocal relationships that children have with the adults in their lives. And by that we mean what we refer to as the serve and return nature of children's interaction with their adults. Development and the impact of experience on development is not a one-way street. It's a back and forth interaction.
This is my next contribution to New Zealand's super diverse future. The status quo is not sustainable. Super diversity stocktake, which I will talk to you about now, is designed to help us to adapt to a super diverse New Zealand, to make sure that we are fit for the future. Because New Zealand is super diverse right now, predominantly in Auckland, but actually throughout New Zealand. Here, we're already 50% Maori Pacifica and Asian. 44% are not born in New Zealand. And we have over 200 ethnicities. Now, the definition academically of super diversity is 25% not born in New Zealand, 100 ethnicities. So we are almost double that number already. And Auckland will continue to become younger and browner as the Anglo-Saxon population ages and shrinks. So the mega trend here is not age. And the mega trend here is not urbanisation. The mega trend is demography. It's ethnicity. And we need to get our head around that, because most of the benefits from super diversity that we as a country are enjoying at the moment, such as greater innovation, productivity and investment, increase New Zealand's financial capital, whereas most of the challenges from super diversity adversely affect New Zealand's social capital.
Today I want to talk about water and the law that surrounds drinking water, to talk about its quality, talk about what your rights are to clean water, to also give you a sense of what key threats are to drinking water, what your exposure might be, and what we might do about it, both legally but also personally. Water is a critical component of our environment and our bodies. Your body is close to 70% water. You can go for several weeks, 2 to 3 on average, without food. You can only go for about 4 minutes without air. And you can go for maybe 4 or 5 days without water before you die. So water is absolutely critical, and one of the key arguments I want to make today is that it's a largely neglected area of environmental law, given the rapid increase in our knowledge about chemical threats to water quality and where those threats come from.
This is a talk about visualizing life without fossil fuels. We have an addiction to fossil fuels, and it's not sustainable. When I say we, I'm talking about the so-called developed world. The developed world gets 80 or 90% of all its energy from fossil fuels, and living on fossil fuels for energy in this way is not sustainable for three fairly obvious reasons. First, on the left, easily accessible fossil fuels are a finite resource, and so at some point that resource will be exploited and humanity will have to do something else. Second, setting fire to fossil fuels puts carbon dioxide upstairs, so we have the climate motivation. The clear consensus of the climate science community is, with substantial error bars still on exactly what might happen, their advice is this is a geoengineering experiment that we're well advised to stop as soon as possible. And third, even if you don't believe in climate change, and even if global fossil fuels aren't running out today, it might be the case that your fossil fuels or our fossil fuels in a particular country or state have run out, and you might have to depend on other countries or states for fossil fuels in the future. So you have a security of supply motivation for saying, let's look into really getting off fossil fuels in a serious way. I find all three of these motivations equally compelling, and I'm just going to take it as given now that we are interested in discussing life after fossil fuels.
I believe listening skills need to be both taught and practiced. Just because you have a pair of ears does not make you a good listener. You can certainly hear things and hear what is spoken to you, but listening is a whole world apart. I must advise you to use what is called effective listening. The very first step of effective listening is tuning in. A good listener must be physically and mentally prepared to listen. One must practice focusing on what is being said with undivided attention. This means that you should forget all the little or even not so little things which come into your mind and focus entirely on what the person is saying. A lot of times, people experience absent-mindedness. They begin to listen to someone speak, and in the course of their listening, random thoughts start invading their minds. This is actually a very normal thing. But the key is to not give your attention to those random thoughts. When this happens, you tend to forget the person who's speaking. What also happens is that we get too focused on listening for the important points, particularly in a lecture, and then make the mistake of not getting certain key details or minor points which can be important to know. What is not said sometimes is just as important as what is being said. I'm making a reference, of course, to inferences. Those are things which are not said, but can be deduced or suggested from what the speaker is saying.
Giving priority to tasks other than those that are assigned and require urgent consideration reflects a form of procrastination. You may ask what procrastination is. The term refers to the habit of delaying work or assignment to reduce the stress. It may result in poor work performance, relationships, and even health. Psychologists often describe procrastination as a way to get short-term pleasure at the cost of long-term output. In this case, people are aware that they should be doing it, but they delay it intentionally, as just the thought of starting it makes them turn frightful. The question arises, what should be done to address this form of procrastination? The answer varies from person to person. The easiest way to overcome the problem is by dividing the work schedule into bits, so that there is no piece of information left behind. Planning here is an integral part of this process. We need to plan the progression of our work, like what needs to be done first, what are the subdivisions, and what are the deadlines. But will merely planning the outline bring the desired results? Nah. We also need to keep a close watch over the progress and see if we are leaving out any key points. Then we need to make sure that we stick to the plans and the priorities.
So it's very important in this context to get at the differences between the hazard and the risk, right? So there's a lot of places around the planet that have a very high earthquake hazard, and these are typically areas on plate boundaries. So we know them. Japan, New Zealand, a lot of countries in Asia, for example, places like Turkey, places like Iran, where they have major fault systems in the plate boundaries. They have a high hazard, but not all of them have a high risk. And what I mean by that is countries like Chile and New Zealand and Japan have high hazard, but they have a relatively low risk compared to some other countries in the sense that the hazard informs their building code practices. So they have stronger buildings, and they have a more earthquake-aware society. They've made more decisions around that context. And so an analogous event in New Zealand compared to an earthquake, for instance, in Haiti, the New Zealand earthquake will have significantly fewer fatalities and injuries. But the flip side of that is when we think about economic loss, because wealthy countries have spent more on their infrastructure and more on their buildings. When they get earthquakes, they have more economic loss. More expensive things get damaged. The Haiti example is a classic example. Over 230,000 fatalities. But the economic loss compared to an earthquake in New Zealand or Japan of a similar extent was much, much lower.
We can ask two fundamental questions about animal behaviour. They're referred to as proximate and ultimate. Proximate questions are those concerned with the mechanisms that bring about behaviour. Ultimate questions are those concerned with the evolution of behaviour. We can divide the proximate and ultimate questions into two sub-questions. For proximate, how does the behaviour develop? And secondly, what causes the behaviour? For ultimate, we can ask, how did the behaviour evolve? And secondly, what is the adaptive significance of the behaviour? What's its purpose? Together, these comprise what are called Tinbergen's 4 questions about animal behaviour. Nico Tinbergen was one of the founding fathers of the study of animal behaviour. These questions represent the different ways of studying animal behaviour, and understanding the difference between those 4 questions are fundamental to understanding behaviour and indeed the whole of biology. How do we study animal behaviour? Well, that depends on the type of question we're hoping to answer.